Scientists now warn that the Atlantic Ocean's vital current could collapse as soon as 2025, triggering climate chaos across Europe and North America. If this happens, winter temperatures in Europe could plummet by up to 15 degrees. Here's what you need to know. If this current shuts down, Europe faces brutal winters, the US East Coast could see rapid sea level rise, and billions in the tropics might lose their vital monsoons. This isn't a movie plot. It's a scenario scientists now say could unfold within our lifetimes. Let's be clear. A collapse of the Atlantic Ocean current would not trigger an overnight ice age like in a disaster movie. But the reality unfolding over decades would be catastrophic in its own right, redrawing the world's climate map. For Europe, the effects would be brutal. Some extreme models predict winter temperatures could plummet, with parts of the continent seeing cooling of 5 to 15 degrees Celsius. This would bring harsher winters, threaten agriculture, and put an unimaginable strain on energy grids. In North America, the most immediate effect would likely be rapid sea level rise along the Atlantic coast as ocean dynamics shift. Perhaps the most devastating impacts would be felt in the tropics. A shutdown could cause a dramatic southward shift in the tropical rain belt, severely disrupting the monsoons that billions of people in West Africa, India, and South America depend on for their food and water. It could trigger persistent droughts in some of the world's most vulnerable regions, while causing extreme flooding in others. As one expert put it would affect every single person on this planet. Imagine the Atlantic current as Earth's central heating system. If it fails, our climate gets thrown into chaos. Out in the Atlantic, there's an immense current perpetually in motion. Its official name is the Atlantic Meridional Overturning Circulation. Think of it as a planet's circulatory system, a global conveyor belt that has function like a planetary heart, pumping heat around the globe. Here's how it works. Warm, salty water from the tropics flows north near the surface. As it heads towards the pole, it releases a tremendous amount of heat into the atmosphere. This makes the water cooler and denser until near Greenland. This heavy, cold, salty water sinks deep into the ocean. From there, it begins a slow journey back south, completing a massive world-spanning loop. And this isn't some minor eddy. The vital Atlantic current is a beast, moving around 15 million cubic meters of water every second. That's more than 100 times the flow of the Amazon River. For the last 12,000 years, during the relatively stable climate of the Holocene, it's been a major active feature of our planet's climate system, even with some past fluctuations. The vital Atlantic current isn't just a river in the ocean, it's a colossal heat engine. The warmth it hauls north is what keeps large parts of the northern hemisphere, especially Europe, far warmer than they would otherwise be. It's why cities like London and Paris have much milder winters than Calgary and Canada, despite sharing similar latitudes. Its influence stretches much further, helping to regulate weather patterns that billions rely on. A slowdown can shift rainfall and monsoon seasons in India, South America, and West Africa. It can even cause sea levels to pile up along the east coast of North America. For millennia, we've built our world around the climate stability it provides, but that stability is now being questioned. The main threat to the Atlantic Ocean current is global warming, and its weapon of choice is fresh water. As global temperatures rise, the Greenland ice sheet is melting faster and faster, pouring billions of tons of fresh water into the North Atlantic, the exact spot where the current's engine is located. This flood of fresh water is like pouring water into the fuel tank of an engine that runs on salt. Remember, the current is driven by cold, salty water sinking, but fresh water is less dense. As it spreads across the North Atlantic, it creates a lighter surface layer that just won't sink, effectively smothering the whole process. This weakening is the central concern of global warming's impact on this system. And there are symptoms. For years, scientists have been monitoring a strange and persistent patch of cold water in the North Atlantic, south of Greenland. It's nicknamed the Cold Blob because it's a region that has cooled while the rest of the planet warms. Many researchers see this as a physical fingerprint of a slowing Atlantic current, though the exact causes are still hotly debated. For years, the consensus view summarized by the IPCC was that while the Atlantic current would likely weaken this century, a full abrupt collapse before 2100 was considered a low probability event. Then, the 2023 study from Danish researchers Peter and Suzanne Ditlevsen threw a wrench in the works. Looking at sea surface temperature records since 1870 for early warning signs, they concluded that if emissions continue, the Atlantic current could reach a tipping point and collapse anytime between 2025 and 2095. This was a shocking departure from the mainstream view, suggesting the risk had been greatly underestimated. But, and this is a big but, these findings are highly controversial. Many scientists argue the methods were too simplified to reliably predict the timing of a collapse. In fact, other recent studies paint a different picture, with some showing the current has been relatively stable over the last 60 years, directly challenging the idea of a steady ongoing weakening. Some experts say we're overreacting. Others warn we're dangerously close to a point of no return. Well, who's right? So while there's no consensus on when a collapse might happen, the conversation has fundamentally shifted. Another 2024 analysis confirmed the Atlantic is on tipping course, even if it didn't give a date. The idea of a collapse within our lifetime has moved from a remote possibility to a deeply concerning risk. The question is no longer if this vital Atlantic current is vulnerable, but how close we truly are to the edge. This is easily one of the most sobering topics in climate science. The Atlantic Ocean current is a known tipping point. It has flipped before, during past ice ages, causing dramatic climate shifts in just a few decades. The scientific community is still grappling with the exact nature of the risk. Is a collapse possible this century, as some newer evidence suggests? Or is it a system more resilient, as mainstream climate models have long indicated? That uncertainty is, frankly, the scariest part. What isn't uncertain is the cause. The relentless melting of ice due to global warming is pushing the Atlantic current toward a weaker state. Whether a tipping point is 20, 50, or 150 years away, we are headed in the wrong direction. This new alarming research serves as a stark warning. We are tampering with planetary scale systems that we depend on for survival, without fully understanding the consequences, and the cost of getting this wrong is simply immeasurable. Do you think we're prepared for a sudden climate shift? Let me know in the comments. And what would you do if Europe suddenly froze over?